Assalamualaikum and good day everyone. I am Ruzaini Rafiuddin bin Rasmet, a PhD student from Universiti Malaysia, Sabah, Malaysia. And today I am pleased to present our study titled Needs Analysis for Developing an EduComic Model to Enhance Problem-Based Learning in Science Education. So this research is conducted under the supervision of Dr. Farha Shaafi, a senior lecturer in science education at the same faculty. The purpose of this study is to examine the need for developing an EduComic learning model that can support and enhance problem-based learning and approaches in science education. Through this needs analysis, we aim to identify the challenges faced by educators and explore how visual narrative tools such as educational comic can improve students' engagement, understanding, and problem-solving skills in science classroom. Problem-based learning, or PBL, is widely recognized as a learner-centered approach in primary science education, allowing students to construct understanding through authentic problems, inquiry, and collaborative discussion. In the Malaysian context, PBL supports key competencies such as problem solving, critical thinking, and sustained engagement, particularly in schools with limited instructional resources, Ong and Tajuddin 2020. However, challenges remain, especially in rural primary school in Sabah. Many learners struggle with abstract science concepts when learning materials lack concrete representation and contextual experiences. In addition, limited instructional supports and resources often result in inconsistent student engagement during science lesson, Jalak Industry 2019. These challenges highlight the need for innovative and contextuality relevant tools to support teachers in implementing PBL more effectively. One promising approach is the use of educational comic, or EduComic. EduComic integrates visual storytelling with concise instruction, text, enabling complex science concepts to be presented through narrative scenarios that students can analyze and discuss. Studies shows that educational comic can enhance motivation, improve understanding of abstract ideas, and support collaborative learning aligned with PBL, Dahliana et al. 2024. However, despite growing interest in educational comic, structured frameworks specifically designed to support PBL in primary science classroom remain limited, reported by Cabrera et al. 2024. Therefore, the study adopts a design and development research (DDR) beginning with a needs analysis to develop an EduComic model framework for supporting problem-based learning in primary science education, Abidin et al. 2022. Specifically, the study identifies teachers' perceptions, challenges, and preferred design features for developing an EduComic model suitable for rural primary schools. I will briefly explain the methodology of this study, focusing on the research design, population, and sampling. The study employed a quantitative research design using a cross-sectional survey method. Data were collected through structured questionnaires, which allow researchers to gather standardized and objective responses from participants. This approach is widely used in educational research because it supports confidentiality, encourages honest responses, and allows efficient data collection from large samples, Yakung et al. 2033. In addition, the questionnaire used closed-ended and Likert scale items, enabling consistent measurement and facilitating robust quantitative analysis of teachers' perception and needs, Abidin et al. 2022. Survey-based research is also recognized as an effective method for generating objective and generalizable data in educational studies, Koch et al. 2022. For the population and sampling, the study applied a multi-stage cluster sampling technique, which is commonly used when the population is large and geographically dispersed. In this study, the sampling process follows a hierarchical structure, which starting with the educational zone, followed by the district, then schools, and finally primary school science teachers as the final sampling unit, Zheng and Xiao 2025. This probability-based approach ensures representativeness of the sample while remaining practical and cost-effective, particularly when collecting data across multiple locations, Koch et al. 2000. I will continue with the instrumentation, validity, and reliability of this study. The research instrument used in this study was a structured questionnaire developed and adapted from relevant literature in science education, problem-based learning, and educational comic. The instrument was specifically designed to support the needs analysis phase of the design and development research, or DDR approach. The questionnaire consists of 5 sections, Part A to E. Part A collects respondents' demographic information, including district of teaching, teaching grade, and years of service. Part B examines teachers' perception of science teaching, particularly student engagement, conceptual understanding, and the implementation of problem-based learning. Part C, identify instructional constraints such as challenges in planning lesson, resources availability, and student participation. Part D, investigates the pervasive need for developing an EduComic model, focusing on aspects such as motivation, conceptual clarity, and curriculum alignment. Finally, Part E explores preferred design features for the EduComic model, including visual representations, hands-on tasks, and collaborative problem-based scenarios. Items in Part B, C, D, and E were measured using a 5-point Likert scale ranging from strongly disagree to strongly agree, which enables standardized quantitative analysis. To ensure content validity, the instrument was evaluated by 5 experts in science education, and the content validity index, or CVI, achieved a value of 1.00, exceeding the recommended threshold of 0.80 by Lin 1986. In terms of reliability, the instrument achieved a Cronbach alpha value of 0.92, indicating high internal consistency and reliability of the questionnaire, MECRA 2005. Data for this study were collected from primary school science teachers in Sabah. Before conducting the main survey, ethical approval was obtained through the Educational Research Application System, or ERAS, under the Malaysian Ministry of Education, as well as the Sabah State Education Department. A pilot study was also conducted to ensure the reliability of the research instrument. The finalized questionnaire was then distributed digitally using Google Forms through official school email channels. Participants were given a 2-week period to complete the survey based on their teaching experiences and their perceptions regarding problem-based learning and the development of EduComics. For the data analysis, descriptive statistics such as frequencies, percentages, and mean score were analyzed using SPSS version 27. Responses were measured using a 5-point Likert scale ranging from strongly disagree with a value of 1 to strongly agree with a value of 5. The interpretation of the mean score follows Lendl mean score classification, where value from 1 to 2.33 indicate a low level, 2.34 to 3.67 indicate a moderate level, and 3.68 to 5.00 indicate a high level. Lendl 1997. Findings of this study indicate several important insights regarding science teaching and learning in primary schools. First, teachers reported that the current level of students' interest in science is only moderate, with a mean score of 3.0. This suggests that engagement in science learning remains a challenge. However, teachers strongly believe that interactive and creative visual materials can significantly improve student engagement. The potential of creative visual material recorded a high mean score of 4.35, while interactive materials score even higher at 4.55. This indicates that engaging and visually rich learning resources are highly valued in science classroom. In terms of challenges in implementing problem-based learning, teachers highlight several constraints. The major barrier is the time constraint for preparing PBL activities with a mean score of 4.29. In addition, the lack of interactive and visual reference materials with a mean score of 3.90 make it difficult to explain abstract and dynamic science concepts effectively. To address these issues, teachers strongly support that EduComic model, which recorded a high average mean score of 4.38, features such as game-based learning, connecting science concepts to real-life situations, and visual storytelling with relatable characters were identified as key elements that can guide students in solving complex science problems and enhance their motivation and conceptual understanding. This study highlights the need for a structured and needs-driven EduComic model to support the implementation of problem-based learning in primary science classrooms. The findings show that although teachers recognize the value of student-centered and interactive approaches, they still face several classroom challenges. These include difficulties in maintaining student engagement, explaining complex and abstract scientific concepts, and implementing PBL effectively due to time and resource constraints. To address these issues, the proposed EduComic model offers a pedagogically grounded and classroom-oriented solution. The model received consistently high level of agreement from teachers, indicating strong endorsement of its design features and learning activities. By integrating visual storytelling, interactive elements, and real-life problem context, the EduComic model is expected to enhance students' motivation, support deeper conceptual understanding, and foster essential collaboration and problem-solving skills among primary learners. Overall, the findings provide a strong empirical foundation for the next phases of this research, which involve the design, development, and evaluation of the EduComic model to further strengthen primary science teaching and learning.